Morning, ma'am.
We were dealing with the hardness of water, permanent hardness and temporary hardness. Temporary hardness can be removed by boiling. That is, temporary hardness is due to bicarbonate. Temporary hardness is caused by the presence of dissolved bicarbonates. So you have to take out the dissolved bicarbonate in the form of precipitate. For that, you can do boiling. So, on boiling, what happens? Calcium carbonate will be produced. So, calcium carbonate and H2O will be there and plus CO2 gas will be going on. This you can remove by filtration. Next, permanent hardness is to be treated with Na2, is to be removed by treating with sodium carbonate. So here permanent hardness is due to the chlorides of calcium nitration, sulfates of calcium and nitration. So CaCl2 plus Na2CO3. Again what you are taking CaCO3 and 2NaCl. NaCl is soluble in water, but this is a precipitate which you can remove by filtration. Next, by permutate method. Permutate means sodium aluminosilicate. Sodium aluminosilicate, which is also called zeolite. Which is also called zeolite. Sodium aluminosilicate. Sodium aluminosilicate means SiO4 4 minus, so this is 3 plus, this is 1 plus. You can write as NaZ. You can abbreviate it as NaZ. When this is treated with this much is Z. Okay. When this permutate is treated with Ca2 plus, for example, calcium, calcium 2 plus means CaCl2, for example, CaCl2, CaSO4. So what happens? Ca will be caught up. Ca will be caught up by Z. That means ZaCl2 and Na plus. Na plus will be going on. Na plus does not cause any hardness. Ca2 plus will be causing Ca2 plus or Mg2 plus, they are causing this hardness. Now, once all this NaZ or and all Z is taken by the Ca2 plus, we say this permutate, this is permutate. Permutate permutate got exhausted. Now, you can regenerate that by passing NaCl solution to that. So, you are passing NaCl solution through this CaZ2. When you pass NaCl, what do? You pass NaCl solution through this. Then again, that NaZ will be regenerated. That is, NaZ will be regenerated. This is the method. So you can write it as NaZ plus what is remaining? CaCl2. So 2NaCl. CaCl2. So you can regenerate this permutate. Again, using this permutate, you can soften the hard water. This is permitted method. What you have to do? You have to pass the hard water. So you have to pass the hard water to the beds of this. There is a big bed in which this permutate is fixed. Through that, you pass this hard water. You pass from one side the hard water, and when the hard water comes out of this bed, it will be soft water. So this is ion exchange method. Ca2 plus is caught up by this permutate. Ca2 plus is caught up by this permutate, and Na plus does not give any hardness to the water. So you will be getting salt water as the outcome. Once all this permutate, when all this Zn2 plus exos, all this Z gets utilized, Z gets utilized, we say permutate or exos. To regenerate that, the next step is what? Fast NaCl solution. So this method is called ion exchange method. Next we are going to hard water. Hard water, that is, if instead of H in H2O, if H is replaced by deuterium, then we get hard water. D2O. D2O is the hard water. Instead of H2O, if deuterium is there, deuterium comes instead of this H2O, H, this isotope of hydrogen, deuterium 1H2, that is hard water. What are the uses of the hard water? I told you hard water is used as a moderator in nuclear reactor to slow down the nucleus. Now, what are the properties of hard water? D2O with SO2. You know that H2O plus SO3 is H2SO4. So here it is D2SO4. Instead of H2SO4, you get D2SO4. Last year you learned for the preparation of acetylene, that is ethyl, C2H2. For the preparation of this thing, we last year we used calcium carbide plus 2H2. This was the reaction. C2H2 plus CaOH twice. So here, instead of this H, now we have D2O. So here C2. So here C2D. To replace all hydrogens by deuterium. So these are the reactions of heavy water. D2O is heavy water. Heavy water. Heavy water is different from hard water. Heavy water is different from hard water. In hard water, presence of chlorides of calcium and magnesium will be present, or sulfates of calcium and magnesium will be present. CaCl2, MgCl2, CaSO4, MgSO4. That is hard water. This is heavy water. Next, we are going to the uses of dihydrogen. Uses of dihydrogen as a fuel. What you have to learn is, otherwise you don't have to learn the uses. Only the fuel. The chemical energy stored in H2 can be converted into electrical energy by galvanic cell. We saw in galvanic cell, using the chemical reactions, we were producing electricity. That is Daniell cell. Daniell cell is an example for galvanic cell. So chemical energy stored in H2 can be converted into electrical energy using galvanic cell. An example of, so in that case, if you are using H2 as a fuel, then we call it as a fuel cell. That galvanic cell is called fuel cell. So galvanic cell designed to produce the energy from the fuels like hydrogen, methane, methanol. Such galvanic cells are called fuel cell. An example of fuel cell is H2O2 cell. H2O2 cell. H2O2 cell. An example for fuel cell is H2O2 cell, which is used to power Apollo space program. And during the reaction, the side product obtained was water. That water was added to the drinking water for astronauts. Now, hydrogen economy. What is meant by hydrogen economy? The basic principle of hydrogen economy is the transportation and storage of energy. Transportation and storage of energy in the form of liquid and gaseous hydrogen. You can store it as liquid hydrogen, you can transport it as liquid hydrogen, you can use it as gaseous hydrogen. So hydrogen is a clean fuel. No pollutants on burning this hydrogen. On burning this hydrogen, no pollutants. So the use of hydrogen as an automobile fuel has many advantages. Instead of this petrol and diesel, now we can use hydrogen as the fuel. Why we are using hydrogen as the fuel? Because release of greater amount of energy per unit weight of the fuel. Lots and lots of energy will be released with a few amount of or less amount of hydrogen. Then exhaust is free from pollutants. Exhaust is free from pollutants like CO, CO2, NO2, SO2, hydrocarbons and lead compounds. Then the combustion product is water. Combustion product is only water. So side product what is coming is water only. This water was used in Apollo space program for drinking for the astronauts. Now, internal combustion engine can be easily modified for the use of hydrogen as a fuel. We are using internal combustion engine that can be easily modified to keep hydrogen as the fuel. So these are the advantages, or this is what is meant by hydrogen economy. Hydrogen economy means transportation and storage of energy. Transportation of hydrogen as a fuel and storage of energy in hydrogen. With that, we finish this chapter hydrogen. Next, we are moving to S block. S block contains alkali metals and alkaline earths. Hard water is different from heavy water. Hard water is different from heavy water. Heavy water is G2O. Hard water is the water which contains calcium and magnesium ions in the form of calcium, dissolved calcium chloride, dissolved magnesium chloride, dissolved calcium sulfate, dissolved magnesium sulfate. That's S block. S block elements means alkali metals and alkaline earth metals. Alkali metals: lithium, sodium, potassium, rubidium, cesium, francium. Alkaline earth metals: beryllium, magnesium, calcium, strontium, barium, radium. Why we are calling it as S block elements? Because the last electron is entering to an S orbital, or we can say S orbitals are progressively fit. S orbitals are progressively fit. Why we are calling it as alkali metals? Because their oxides and hydroxides are highly alkaline. Why we are calling the others as alkaline earth metals? Their oxides and hydroxides are found. They are found in Earth's crust. In alkali metals, now we are concentrating only on alkali metals, that is sodium, potassium, rubidium, cesium, francium. In this lithium, sodium, potassium, rubidium, cesium, francium are the alkali metals. In this, lithium is less abundant. Lithium is less abundant. Rubidium is less abundant. Cesium is less abundant. But sodium and potassium, they are most abundant. In our body, there is sodium. Little bit of sodium is required for our body for the proper functioning of brain. Otherwise, uh, if sodium is not there, army becomes little mad. They show little madness like old people at the age of 85, 90. They show little madness like we say because of the less amount of sodium. If the proper amount of sodium is given to their body, they will be all right. So sodium is very much required, only in less amount, but it is very much required for our body. Potassium is also required for our body. This Na plus and potassium ions, K plus ions are found in our body fluids. They perform important biological functions such as nerve impulse conductors. In our body, there is conductivity. In our body, there is conductivity. It is of electrical. These ions are movement of ions, that is electricity. Movement of ions means electricity. Now coming to this alkali metals, sodium, potassium, lithium, sodium, potassium, rubidium, cesium, francium. As we move down, the size increases because new shells are getting added. But in a period, alkali metals are having the biggest size. In a period, alkali metals, for example, sodium, then magnesium, aluminium, like that. The size decreases. The size decreases. So sodium is having, or this alkali metal, in a period, alkali metal is having the greatest size. And the last shell contains only one electron. We know that interaction of unpaired electrons is called metallic bonding. It has got only one electron in the last shell. So between one sodium atom and other sodium atom in sodium metal piece, there is not much force of attraction. We say metallic bonding is less. We say interaction of unpaired electron is very less. So there is very less metallic bonding. So they are very soft metals. That bonding is not there between two sodium atoms or between two potassium atoms. So sodium is a soft metal. Sodium is a soft metal that you learned last year. There you learn sodium metal piece can be cut with a knife. Of course, we do in the laboratory. We cut sodium metal piece with a knife. But you cannot cut an iron piece with a knife because in one iron atom there are so many unpaired electrons. One iron atom will be interacting or attracting with this other iron atom. So there is metallic bonding, strong bonding. So they are very much close to each other. You cannot cut an iron piece with a knife, but you can cut sodium metal with a knife because one sodium atom is not attracting the other sodium atom. Metallic bonding is not there. What is meant by metallic bonding? Interaction of unpaired electrons, that is called metallic bonding. Now, we say alkali metals are soft. Alkali metals have low melting and boiling point. Why? Because no interaction between the atoms, so they can be easily melted or they can be easily boiled. Alkali metals have low density in a period because size is bigger. Size is bigger, so they have low density. Next, coming to the detection of these alkali metals. Alkali metals impart particular color in flame. So here, alkali metals is, if alkali metal is present, if you show that alkali metal salt, especially chlorides, in flame, you will see particular typical color. For example, if you see yellow color, suppose you take a little bit of common salt, sodium chloride, and show on the blue flame of your, you take in a spoon and show on that flame, blue flame, you will see yellow color. So if it is yellow color, that is, it is a sodium compound. So alkali metal, Na plus, that alkali metal can be identified by, alkali metal can be identified by this flame test. This test we are calling it as flame test. So if a salt is available, you convert that into chloride because chlorides are highly volatile. Suppose you got sodium sulfate. You add 1 drop of concentrated HCl and make it into a paste. That means sodium chloride is formed. Chlorides are easily volatile. So these Chlorides will be volatile, means they will be moving as gaseous state, in the gaseous state. So when these gaseous state gets in touch with that flame, it will catch fire. It will catch fire means that the fire will be having a particular color. If it is yellow, we say sodium. You must have seen sodium vapor lamp as the street light on the roadside, like this one lamp you must have seen, red, yellow color. Night it lights with yellow color. That is sodium vapor lamp. Sodium atoms are heated there by passing electricity. So electrons gets promoted to higher energy level. There they are unstable. They fall back to the lower energy level by emitting the absorbed amount of light in visible region. Visible region means VIBGYOR. So there it will be emitting yellow color. In VIBGYOR, it will be emitting yellow color. So that yellow color we are seeing. Lithium burns with lithium chloride or lithium salts will be burning with crimson color. Crimson color, sodium yellow, potassium lilac color. If you show potassium chloride on this blue flame of your gas stove, it will be burning with lilac color. Lilac color, you know the color of lilac hotel, the same color, somewhat light purple color type, lilac, and rubidium is red violet and cesium is blue. So these chlorides or their compounds impart a characteristic color. That's how you can detect the presence of this particular ion in that salt. Now coming to the chemical properties of these alkali metals, they are highly reactive. They are highly reactive because their size is bigger. The outermost electron is not under the control of nucleus. So that electron can enter into chemical reaction. That electron can participate into the chemical reaction. So these alkali metals, lithium, sodium, potassium, rubidium. This is lithium, sodium, potassium, rubidium, cesium sizes are bigger. So the last electron is not under control of nucleus. That can go out, means it is gone out. Cesium, the size is so big. The last electron is already free to go out. In solar panels, cesium plates are kept. Cesium plates are kept means its ionization energy is very less. Its ionization energy is very less. That means that electron can be easily taken out. The cesium plates are kept in Chambal garden. You must have seen the solar panel in which cesium plates are there. Uh, in cesium, those plates are made up of cesium atoms. In the cesium atoms, that last electron can mix when the sunlight falls. This electron, the sunlight is more than enough to release, to give the ionization energy for cesium. So the last electron will be going out. So we say alkali metals are highly reactive because of that one electron present in the outermost shell. Coming to the oxides, when it combines with oxygen to form oxides, these alkali metals, there are monoxides, peroxides, superoxides. Monoxides, that means only one oxide, Na2O, Li2O. Peroxide, Na2O2. Superoxide, RbO2, KO2, that is superoxides. Li2O, that is monoxide. Na2O2, this is peroxide. Then superoxide, KO2, RbO2, CSO. These are peroxide. These are peroxide. Superoxide. In superoxide, you know, the oxygen state is minus half. Minus half. So 2 oxygen means minus half plus minus half. So minus 1 oxygen is plus 1. You know that potassium is plus 1. So in superoxide, the oxygen state of oxygen is minus half. In superoxide, Oxygen state of this oxygen is -1. Potassium is +1 only. That's about the oxides. With water, what is the reaction with water? The reaction with water means you know that these fellows are highly reactive with water. When you put in water, it will catch fire. Sodium will catch fire. Potassium will make explosion. Cesium, if it is cesium, it's a big explosion. In YouTube videos, you can watch, just search in YouTube videos. You type the reaction of alkali metals with water. You will see beautiful, beautiful videos. There, they are putting cesium. They are putting cesium in sea water. In ocean, they put cesium, and the whole water from large area is coming up due to a big explosion. You can see large amount of water coming up with explosion. This was that video. That video was morphed. That video was morphed, and they made some other small video as a fat lady jumping into that sea water, and lot of water was coming up. Coming up. That was actually cesium video was morphed, edited and made it. So you watch the YouTube videos of these reaction of these alkali metals with water, fantastic videos you'll be getting. So Na plus H2O, Na plus H2O, you know that hydrogen is produced. This is a highly exothermic reaction. Highly exothermic reaction, so it catches fire to uh, hydrogen catches fire due to this exothermic reaction. Hydrogen catches fire and you see fire on the water. In redox reaction, we have learned this reaction. Now, what about lithium? Sodium catches fire, potassium explosion, and the cesium, big explosion. I told you in sea water it is put. But lithium, though its E0 value is the highest, due to its small size due to the small size of lithium, due to the small size of lithium, due to the small size of lithium, uh, means it gets hydrated easily. It gets hydrated easily. As the size decreases, hydration enthalpy increases, or it gets wet. So it will not catch fire. It gets wet. So though lithium has got high E0 value, you know that minus 3.05 volt. It gets wet, or we say it gets hydrated, so it will not catch fire. The reaction of lithium with water is not aggressive. Reaction with lithium with water is less vigorous. Why? Because lithium size is small, so it gets hydrated easily. We say gila ho jate, so it will not catch fire. You will not see fire. Lithium gets hydrated and what is formed LiCl dot 2H2. This is a hydrated water. We learn hydrated water molecule BaCl2 dot 2H2. This is again hydrated water LiCl dot 2H2.